It's my pleasure to introduce Nicolás Eiris. He's a machine learning engineer at TryoLabs. He has a background in price forecasting and computer vision projects. He has a bachelor's in computer engineering and a master's in big data.
Thank you so much for the presentation. Hi all, I'm super happy to be here. Today I'm not going to present a state-of-the-art model, but I'll present some insights and a useful tool to boost the productivity of your development team and improve the operative of your development team. So today I'll be talking about data versioning towards a good reproducibility in machine learning pipelines. So a few words about TryoLabs. We build custom AI solutions working on computer vision, natural language processing, and predictive analytics, thanks to a team of more than 70 people and more than a decade of experience serving over 150 clients. Regarding the agenda, I'll open this talk by introducing some common pain points in the machine learning development experience. Then I'll present a useful open source tool that helped us alleviate some of these problems during development. And then I'll share with you some takeaways and learnings from our experience, along with some references for you to deep dive on this tool and speed up the onboarding process. So, as I was mentioning, in TryoLabs we have a very big team, mostly composed of data scientists and technical people who are always looking to solve new problems and challenges from the industry. During our history as a company, a dilemma arose regarding implementing entire solutions from scratch versus adopting tools to solve some of these common problems. Usually, data science teams end up reinventing the wheel for these common problems, and today I would like to present you a successful tool to help you avoid these common patterns that threaten productivity. So, which are these main pain points I'm talking about? So here we can see a standard machine learning workflow, starting with the data ingestion and ending up the cycle with the deployment of the system into production. During these stages, we need to face common issues as the following. While iterating over the different stages of the solution, we start accumulating different versions of data, analysis, features, and models. Considering that there's a team behind the implementation and requirements are volatile, managing different versions of data starts to be a problem as the project advances in time. That's why the joke at the end of the flow with rage quitting the job, because this not only affects the project itself, but also the motivation of the team. As a consequence of this phenomenon, we need to face common issues as, for example, reproducibility. A typical problem is when you and your coworkers have the same source code, but pipeline execution has different results. Reproducing pipelines and experiments is still an area of improvement, where usually teams create ad hoc and manual processes to deal with reproducibility. This generates a productivity bottleneck, usually caused by changes in datasets, hyperparams and randomness inconsistencies in modeling algorithms, and manual execution of experiments. With this last point, I mean, for example, running cells of a notebook in different orders. An example of the materialization of this pain point relates to one of our projects for a client, where the team was composed of 2 coworkers and myself. During business and data understanding using the CRISP life cycle, we implemented a couple of Jupyter notebooks with raw client data. Despite having the source code version and the same input data, we detected a productivity bottleneck since every time any of us changed a piece of code impacting data, the other teammates needed to re-execute the entire pipelines again. If, for example, developer A implements the first section of a notebook and developer B the last section of this notebook, every time developer A makes any change to the first piece of code, developer B needs to re-execute the entire notebook, and imagine if one of these steps takes several hours to process. These are just a few examples of how manually dealing with reproducibility may be a risk for the project health. Another of the most common pitfalls when developing machine learning projects is data sharing within the team. This is usually a problem, and even more when dealing with large data sets. READMEs usually end up having a step-by-step on how to get the latest version of the dataset from the remote storage. In addition, managing data versions using an ad hoc approach may be a risk for both security and data privacy. Specifically, computer vision projects are the one with more need of a mechanism to automate and simplify the data sharing process, since a large amount of images or videos are usually used as raw data. For example, when implementing Norfer, our open source object tracking library, we needed to train and validate our solution using a large amount of videos and images. And sharing this data was one of the most challenging tasks during the project. To train the object detection models, we used our on-premise servers with GPU latest technology, but for GPU non-consuming tasks, we wanted to use our local boxes for simplicity. We ended up developing the entire solution in the servers because sharing such a large amount of data was a bottleneck during this process. This gave us the idea to search and investigate for a tool to alleviate this problem specifically. So before moving forward, I would like to point out experiments execution and results traceability. There are very few ways and tools to automate this process. Usually we run experiments in a very manual way and register both experiment setup and results in spreadsheets, GitHub metadata files, or even some tracking tools, where usually implies some time for adoption and training on the team. So before moving forward, I would like to make this presentation a little bit more interactive, and I would like to ask the audience to please raise your hand if you have any experience working on machine learning development. Okay, cool. Now please raise your hand if you never faced any of these issues during development. Okay, cool. So as we can see, this is a very common pattern, and despite the industry you are working on or the size of your team, are common problems that we need to solve. So in TryoLabs, we think that the ideal development experience starts by having a structured pipeline composed by interdependent steps, where each of these ones has a standard formal definition. With this, I mean defining for each of these ones inputs, source code to execute, and outputs, favoring maintainability by supporting a high cohesion and low coupling between the modules. Easily adding certain files or directories to a remote repository for other teammates to use in their environments is a very supporting experience. This not only alleviates the tasks of sharing data, but also supports security and data privacy. Another nice-to-have feature would be sharing in a reproducible way raw and processed data, models, features, and any other intermediate output the pipeline generates. This may save many hours of executing the pipeline each time something is modified. Having an out-of-the-box association between the source code and the data enables developers to focus on developing code and not worrying about data versions or data consistency. So I dealt many times with this type of problems, and it was very important for me to find a tool to solve these problems and help me do my job the best way possible. Here is when we found DVC, which stands for Data Version Control, which is basically a Git for data with many interesting features. So as a high-level overview of the tool, DVC encapsulates all the data inside each commit, generating a valuable association between the source code and the data. As you all may know, storing data in Git is a bad practice. So we usually end up creating complex guidelines on how to download and keep the data up to date. Instead of doing this, DVC saves reference file in the Git repository in order to fetch the data from the correct location in the remote repository. This way, each commit saves a reference to a specific data version, generating an easy and valuable association between the code and the data. As I was mentioning, each commit contains features, models, plots, experiments, and any other data generated with that specific source code. This data will be stored in your local cache, and if you want to share it with your coworkers, you can upload it with a single and simple command. With DVC pull and DVC push, you can download or upload data to the remote repository in a very easy way. This enables an easy collaboration between the team and also an easy way to generate new deployments to production if needed. So, which are the main features of this tool? Git compatible. This tool runs on top of Git, so it's compatible with any Git server or provider, such as GitHub, GitLab, etc. Storage agnostic. You can choose from a variety of remote repositories to store the data. For example, Google Cloud Storage, Google Drive, Amazon S3 buckets, Azure, SFTP, etc. The list of supported storages is constantly expanding. Reproducible. By simply downloading the source code from a specific Git branch and setting up the remote repository in your local box, you're going to be able to run the entire pipeline with a single command called dbc repro. Low friction branching. As dbc is built on top of Git, dbc will save reference file to a specific data version in the source code, and switching between branches does not imply re-executing the entire pipeline again. dbc will download the files from the remote repository from these references without duplicating files remotely. ML Pipeline Framework. dbc provides all the boilerplate code necessary to quickly build an end-to-end machine learning pipeline, with the support of dynamic parameters to favor both maintainability and reproducibility along the entire flow. Language and framework agnostic. Pipelines are based on input and output directories or files, so the language does not matter. For example, Python, R, Julia, Scala Spark, custom binaries, TensorFlow, PyTorch are all supported. Track failures. Retaining knowledge of failed attempts may save time in the future. So dbc is built to track everything in an easy and accessible way. Experiments and metrics tracking. dbc provides command to list all your Git branches along with their metrics values for you to choose the best option, and also a way to run experiments in parallel. So, pipelines creation has never been so easy for us as with dbc. With a single file, you can define the structure of your data flow by creating interdependent steps composed by dependencies, code to execute, and outputs. Besides the definition in a YAML file, you can visualize the directed graph of the flow with dbc-dag command. When experimenting and changing the pipeline, there's a very intuitive way to compare results with the baseline's results. By simply executing dbc metrics diff, dbc shows both numeric and graphic visualizations of the difference between my current work and the base results in production. As mentioned before, an end-to-end machine learning workflow also involves designing and executing tasks related to both production and testing environments. Thanks to dbc, you are going to be able to automate data version checks, benchmark new models against previously deployed ones, show metrics differences and interactive plots in pull requests, and also you are going to be able to retrain and refine models in the cloud. Executing multiple experiments, it is not a time-consuming task anymore. With dbc, you can queue multiple executions of the pipeline with a combination of different parameters and execute them all in parallel. In one of the latest projects I have been working on, we needed to train an image feature extractor for a tabular classification model. To train the image feature extractor, we queued a set of experiments by combining different hyperparameters of the ResNet model and left it running an entire night. The following day, we had the results and quickly moved forward to the next phase without losing too much time with the experimentation phase. This generated a significant productivity boost in the operative of the team. dbc Studio is a UI to manage your project, and this is how it looks like. I'm going to zoom in to show you some interesting features. You can show interactive plots. You can also compare results between experiments in different Git branches, and you can also run new experiments. In addition, you are going to be able to generate trend charts and all these features by just simply interacting with your browser. So, which are the main takeaways and learnings from our experience? Okay, so first of all, adopting a transversal development support tool may be crucial for the project to end in time and with high level of quality. Dealing with the pain points I presented before implies losing time developing code that does not deliver real value to the end users or customer. it's important to understand that developers should focus on coding features that then transforms to business outcomes. As in standard software development, machine learning projects also has non-functional requirements, which then converge to certain quality attributes. Using this type of tools, you are going to be able to favor maintainability, scalability, and security with almost no effort from the developer point of view. This tool not only supports the development experience, but also the deployment experience, being an end-to-end support tool. So what about the pain points I mentioned before? With a couple of commands, you can replicate the environment state of your team without executing a single line of code. This was very useful, not only for me, but for our technical team in TryoLabs, because sometimes, for example, when you left a project behind the past and you want to start over and resume the development of the project, sometimes it's annoying and takes several hours to set up the project again and sync data and code. So with this tool, you can set up a project again in a couple of minutes instead of hours. So boost the productivity of the team by running multiple experiments in parallel with a friendly visualization of the results. You can compare results between different Git branches and quickly have a big picture of how your data flow is working. Avoid having complex readmes, chats, or even a call with teammates to sync data by having an out-of-the-box association between the code and the data. So, in TryoLabs, we learned that for most of the cases, using an all-in-one framework like DBC helps us to end the projects in time and with high level of quality versus manually dealing with these pain points such as reproducibility, experimentation, and data sharing tasks. From our own experience, this was super helpful because it enabled us to quickly build the solution without losing too much time with the setup and these transversal development tasks I was talking about. So in addition to this, DVC has a very active community. They have both Discord community and GitHub communities where you can upload issues and people will be very happy to help you there, and you can solve your problems in a couple of hours. So here are some resources for you to deep dive on DVC and to speed up the onboarding process. I also leave a link to Norfer, which is the TryoLabs object tracking open source library. And that's it. Thank you so much, and I'll receive your questions in a while.
So for questions, if you could go to the microphone so that the questions can be recorded, that would be appreciated. Let me ask the first question. Can you talk through the learning cycle or the learning curve that people have gone through in order to kind of adopt the tool?
That's a very interesting question. As I was mentioning before, this tool was adopted internally in TryoLabs, and it has been used extensively now. At the moment of adopting it, we were facing these issues, and we were like, okay, we need to find a tool to solve these problems and alleviate these pain points. Fortunately, we found this tool, and in a couple of weeks, we were implementing a solution with this tool, specifically for a client after the training phase internally. So if you have experience developing machine learning projects and you understand about data, perhaps in a week you are going to be able to work with this tool.
And then we've heard a lot about the benefits. Can you talk about any of the trade-offs involved, as well as maybe how it applies to production?
Yeah, of course. So one of the disadvantages of this tool that we found in TryoLabs was specifically when experimenting. As I mentioned, you can queue multiple experiments and leave it running over there. This tool doesn't have a good way to monitor and alert when something goes wrong. So we left experiments running an entire night, but the first night it failed. Sometimes happens. And we didn't notice about this. So next day we went to the office and it was like, okay, this experiment failed. So it would be very helpful to have a mechanism to alert you when something goes wrong in order to jump in and roll back the experimentation phase.
And then a different question. How do you handle branch merges with data?
Okay, so as I was mentioning, this tool is built on top of Git, so you won't have any problem when merging branches and like opening new branches, because every commit has a specific reference to a specific data version. So if you merge a branch and a specific file didn't change, that won't be affected. That's an interesting question also to let you all know that when you track files with this tool, basically you have your files in your local system, and DVC will create these references files, which are hashes of the data. So if your data didn't change, the hash will be the same, and you won't be duplicating files remotely.
So the users kind of have to know which files change. They don't really look within the file to kind of understand. Okay.
I have experimented with DVC a while back. One of the points I noticed that was if your data set has tons and tons of samples, sometimes the hashes that it takes it generates a set of reference hashes to keep track of those files, right? I noticed that it takes a long time for that entire process to happen. Is there a way to kind of improve that, especially when your data sets are quite large?
So when data sets are large, perhaps what you can do are split them in order to have an easy way to track the changes. But there's no intuitive way of accelerating the process of downloading or uploading the data sets when they are changed. So I don't know if I answered your question or not.
Yeah, it's more in terms of how I guess Git functions fundamentally, because you have to kind of encode each file that you're tracking as some sort of hash, right?
Yeah.
So what you do it with source code, and when you extend the same principle to data, essentially now you have like thousands of files that you have to keep track of to generate the hashes and so on. So I've noticed that whenever you deal with a lot of large data sets, that process is not very, it's not trivially fast.
Yeah, that's true. When we developed this tool with a large amount of images and videos, the first time it takes some time because it needs to hash the entire data set. But then after that, every time you change something, it will change only the specific file you are changing. So you don't need to reprocess all the entire data set again.
Also, if you have to, you spoke about DVC being an end-to-end kind of thing, right? So when I was looking into DVC, I was mostly looking at it as some sort of data versioning or model versioning framework. So when how does DVC exactly apply towards the production side of things?
Yeah, that's a very interesting question. Okay, so this tool was built for development purposes, and then these people started adding more and more features that enabled the tool to be an end-to-end tool. In production, you'll need to assess if it's a good fit or not for your specific project. For example, if you're talking about a real-time vision application, I wouldn't recommend DVC perhaps. But for example, in one of our projects that we needed to, for example, predict prices every day for a client to change the prices in Amazon, that was great because it was just a job that ran every day. So depending on the specific case scenario you are working on, it may be worth or not. But it supports production also.
Does DVC work well with containers?
Sorry, I couldn't.
Does DVC work well with containers?
With what?
Containers?
Containers, yes. Yeah, I mean, for example, in our case, for this type of solutions, we use Docker and we run DVC inside the Docker container. So it's super helpful.
Thank you.
You're welcome.
If there are no more questions, let's thank the speaker again.
Thank you.
Thanks for watching. If you enjoyed this product update video, please like and subscribe. Thanks, Stevie. And feel free to post comments and questions below. Beyond our tools themselves, we have many resources for you on your ML journey. Visit our docs, our blog for tutorials, our YouTube channel, our Discord server for support and community, and our free online course. You can find all the links to these resources in the description. Thanks for making it to the end. Devi and I will see you in the next video.